In lesson 16, we work on solving inequalities with ands and ors. So in this particular inequality, it's an or, and it says x minus 2 is less than 6, or x over 3 is greater than 4. And we want to be able to solve and graph this solution set on a number line, as well as write a solution set. So the first one, in order to solve it, we need to figure out what numbers work. And in order to do that, we need to get x by itself, and we need to get a number on the other side of the inequalities. So again, same rules apply when we're solving inequalities as they do when we're solving equations. The only thing we have to look out for is that when we multiply or we divide by a negative number, because negatives are opposite of positives, the inequality sign changes the direction, because when you multiply a positive number by a negative, you get a negative, so you're flipping the sign of the number and hence flipping its value. It's like when a negative 22 is bigger than a negative 25. That's not true when you're dealing with positive numbers. A positive 22 is smaller than a positive 25. So because it changes the logic, we're going to change the signs. So the only thing we got to look out for is just multiplying or dividing by a negative number. And there's ways we can avoid that using the strategy of picking on the little guy, for instance. That will work. We want to move an x, if there's x on both sides, and we want to move an x over. We want to pick on the small one so that we make sure we end up with a positive x. But this one's all set. There's no negative numbers we have to worry about. Adding and subtracting, that does not apply to. So I can definitely add 2 on both sides, keeping my inequality balanced. And I'll end up with x is less than 8. Or, and this one, I have this nasty fraction. I want to get rid of the denominator and make it a regular number. So I can multiply by 3 on both sides. 3 over 3 is 1. And 4 times 3 is 12. So I end up with x is less than 8 or x is greater than 12. Now the nice thing with ors is that they include everything. So it's either or. It could be that it's less than 8 or it could be that it's greater than 12. So if I were to draw a number line, I want to make sure I include 8, make sure I can include 12, and then let's include the numbers in between. And then we have to decide, do I want an open circle or do I want a closed circle? Closed circle means that it includes the number. An open circle means it does not. So when I say x is less than 8, it cannot be 8. It has to be a number that is smaller than 8. So I'm going to have an open circle at 8 because it cannot include 8. And then it has to be less than. So I shade to the left. And on the other side, we have x is greater than 12. It cannot include 12 because there's no equals to sign underneath the greater than sign. And since it's greater than, I'm going to shade to the right. And it's that or that. It could be on the left-hand side or it could be on the right-hand side. It does not matter. The solutions are many in number. Let's try an and. Now, I picked this one because it's interesting. This is an and. It is saying that, if I separate it out, it makes sense. Negative 6 is less than x plus 1 over 4, and x plus 1 over 4 is less than or equal to 3. So we could solve them separately, but the cool thing is that we can solve them together. Okay? So the way we do that is we want to get rid of that fraction in the middle. We want to get x by itself. So what we end up with doing is multiplying each term by 4. We have to do it all the way across to keep that inequality balanced. So 4 times negative 6 is negative 24. We're left with x plus 1 in the middle, and we're left with 12 on this side. So we've kept the inequality equal, or not equal, but even, And we've gotten rid of the fraction. And now all I have to do is get rid of that 1 that's being added onto the x. So I can just subtract on all the terms, and I'll hit x is less than or equal to 11, and x is less than negative 25. So here what I'll end up with is two different inequalities, basically saying that, I'm going to get rid of this stuff down here. That x is between negative 25 and 11. Now when I graph this on the number line, this is kind of a tough one to graph on the number line, but basically get your number line. It needs to have 11 on it. And on this side, maybe I don't want to label 12. Let me think about this. If we go by ones, that's a lot of dashes. So what I'm going to do is I'm going to go by fives. So negative 20, negative 15, negative 10, negative 5, 0, 5, 10, 15. And I'm going to throw an 11 in there. Okay. Then we're going to have an open circle on negative 25 because there's no line underneath that inequality symbol. So we can't be equal, so it's open. With the second one, there's definitely an equal sign. So it can be 11. So what we do is we shade that circle in, because that means it can be 11. And then x is between those two things. Any of these numbers in between will work. So negative 5 will work, 1 will work, 7 will work, negative 19 will work, and you get the idea, but any fraction between there should work too. So if I put in a half, even though it might look a little messy, it'll end up working when I work it all out. And if you don't believe me, you can even plug some of these values in. So take the original equation. Let's pick a number that's in our graph. How about 5? So where I have an x, I'm going to put a 5. So I'm going to get 6 divided by 4. And that means I'm going to get 1 and 1/2. Is 1 and 1/2 greater than negative 6, but less than or equal to 3? Yes, this is a true statement.